Welcome to LabMinutes.com and our lab video series in BGP. You can find a complete list of BGP video on our website by clicking on the link above and sign up for our newsletters to receive the latest video updates. I'm sure all of you guys have heard that BGP is a routing protocol since it's been around for a while now, but from the high level, BGP is a routing protocol that's mainly used to exchange routes with external networks. Although BGP can also be used internally due to its features and stability, and there's absolutely nothing wrong with doing that, but I have to say that it's much less common since you have another routing protocol like eBGP or SPF that is specifically designed for internal routing that you can use, and usually they are much simpler to configure. So in a regular enterprise network, you would normally find BGP being used for peering with your internet provider when you want to receive more than just a default route, or for connecting to your MPLS provider. Now in the service provider network, BGP is predominantly used for internet routing exchange obviously, as well as network services like building a MPLS VPN. Unlike other routing protocols that use multicast for neighbor discovery, BGP is based on unicast and specifically it writes on TCP port 179. Also, BGP does not do automatic neighbor discovery, which means that you have to manually define which device you want to build a BGP session with. Since the first thing that you need to do is to create and form a BGP neighbor adjacency before you can really get into the configuration of the routing policy. This kind of leads us to our first lab, which is BGP basic neighbor configuration. In this video, we're going to be configuring BGP neighbor and we're going to try to establish iBGP and eBGP sessions. We're also going to look at the features called Fast-External-Fallover as well as the Graceful restart and see how we can enable or disable those features. Since this is the first video of our lab video series, let's spend a little bit of time familiarizing ourselves on our network topology. This is a physical topology that we're going to be using throughout our lab video series for BGP. So we have 7 routers altogether, R1 through R7. And the way we have these routers connected between R1, R2, and R5, we have them connected in full mesh over a point-to-point serial link, as well as on the other side, we have the same thing going on between R3, R4, and R6, again connected in full mesh over the serial link. And now we have in the middle right here, VLAN 123 that connects the two groups of routers together with R2 and R1 connected to R3 and R4. Now on the right hand side, we have R7. This kind of sits by itself. That's only connected directly to R2 over VLAN 27. And also make a quick note as far as the IP scheme, the way that we have it laid out, everything starts with 172.16 and in the third octet, as you can see, for the most part, designate the 2 routers that participate on that particular link. For example, between R4 and R6 right here, we have the third octet being 46 and then the last octet being the router number itself. Okay, so it's .4 on R4 and it's .6 on R6. By default, each of these routers contain 4 loopback interfaces. You can see listed right here, loopback 0, 10, 11, and 12. We're going to be primarily use loopback 0 for our iBGP source interface as we progress through the lab, while the loopback 10 through 12, we're going to use that to simulate our network that we're going to be advertising. Okay, and again, an IP scheme right here, X designate a router number. So for a router 1, loopback 10 will be 1101, for example. Okay, and this diagram is going to be made available for you guys to download just in case you want to kind of build your own lab and follow along our lab video series and trying to do the configuration yourself. Okay, so moving down to the next page, we have our layer 3 network topology. And this is how we're going to divide all of our routers into a different autonomous system. And here we have R1, R2, and R5 under the AS number 100, R3 and R6 under AS number 200, R4 and AS 300, and the R7 on the right hand side here, again sitting by itself in the AS 65-123, which is the private AS number. Each of these black lines right here designate a BGP sessions, and those are logical and not really a physical. As you can see, when the line crosses between the two autonomous systems, the link or the session is labeled as eBGP, and when the line stays within the same autonomous system, the session is labeled as iBGP. Now within the AS, we have an internal routing protocol, ISIS, running to advertise the router loopback interface, and this is just a flat level 2 ISIS. You can see these are the net IDs configured on each of these routers. And these are configured for AS100 and 200, and this is how these routers will be advertising its loopback and learning each other's loopbacks to build the iBGP session. Now that we kind of understand the network topology that we're dealing with in this lab, let's get started with our configuration task number 1, iBGP neighbor establishment. So we're being asked to configure a full mesh iBGP on R1, R2, and R5, and these routers are going to be under autonomous number 100, and we also need to source all of our BGP connections from the loopback 0. Okay, so what we're going to be configuring right now is these iBGP session right here. Okay, so let's go ahead and get into the console of R1. Before we start our configuration, let's do a basic connectivity check between R1, R2, and R5. So first start off with by show ISIS neighbor and make sure we have a ISIS neighbor adjacency, and we do. Right here, R1 to R2 and R5. Type is level 2 of their 0 interfaces. Okay, we can do show IP route ISIS just to make sure the R1 is seeing R2 and R5 loopback IPs. You can see right here 0.2 and 0.5. Okay, and then we can try to ping their loopback just to make sure. So ping 0.2 sourcing from its own loopback 0, and you can see that's pingable. And we can try to ping 0.5 as well, and we have that come back as a pingable IP. Okay, now let's start with our configuration. So go config T and then router BGP, and this is, we have to specify the R1 autonomous system number, and we say it's going to be 100. So one of the most common things to do as soon as you get under the routing process configuration, this is not true just for the BGP, and actually it's for other routing protocol for the most part, is to do a no auto summary. Okay, and just for the BGP, and another, our second command that we normally do is to disable the synchronization. Is just to disable the default behavior where the BGP routing process needs to see the exact same route in the IGP routing table before it actually advertises out that particular routes. So we can go ahead and do no synchronization. And then again, common task, which is specify a router ID. And we're just going to use our loopback 0, 172.16.0.1 for that. Then we can specify our neighbor using the neighbor command, followed by the IP address. And we said everything is going to be use the loopback IP. So for R2 is 0.2, and that's our first neighbor that we are configuring. And you can see after the neighbor command, or in the IP, there's a lot of options that you can configure, and these will be reviewed for the most part in our future lab videos. But just to get the neighbor adjacency up, all you need to do is to configure remote AS to specify what AS number the neighbor is in. And since we're doing iBGP, it's the same AS for router 2. And then in order to source from loopback interface 0, we use the command update source. And then if you question mark, you can specify the loopback interface 0. Okay, we do exact same thing for router R5, which is the loopback of 0.5 for our neighbor IP, remote AS 100. And then actually I can just go up arrow, find the update source loopback 0, and then change the IP to .5. Okay, so let's do a quick show run to look at the configuration that we've done so far. As you can see, router ID, BGP log neighbor changes, that's there by default, and 4 of our neighbor commands. Okay, so those are the required commands just to bring up a BGP neighbor or BGP session. Okay, so what we can do, we can just go ahead and copy this. Let me bring up a notepad. As you can see, the command is fairly similar, so we can just do a copy and then change this for our next router, which is R2. Okay, we started our configuration with no auto for no auto summary, so let me type that in, and then no sync. You might have noticed that those two commands did not show up under the configuration. That means those on the new version of iOS might be the default command already. So, but just to be safe, or you might get used to the habit of typing those two commands in anyway, although it looks like the newer version of iOS has those commands set as a default. Okay, so for R2, we still have router BGP 100. We're going to change the router ID to 0.2 to reflect the R2 loopback interface, and then the neighbor is going to be pointing to a router 1, R1, and R5. Okay, so we can just as easy as copying this and then paste it for R2. On the R5, it's going to be almost exact same thing, changing the router ID to 5, but the neighbor is going to be .1 and .2. Okay, as you can see in the background here, we have our log for neighbor adjacency change. And that means R1 and R2 session, BGP session is already up. Let's go and get into R5, paste it, wait for a few seconds here, and there you go, our neighbor came up. And we go back to R1 and then do show IP BGP summary. You can see the summary of all the BGP sessions that R1 currently has configured. And that's going to R2 and R5 AS number 100. For the most part is version 4. Usually that never changed. And then here's the uptime. And so far, since we have not really advertised any routes, the receive prefix 0. So that's pretty much accomplished that particular task. Now, the next one said we need to do pretty much the same thing between R3 and R6. But this time it's going to be autonomous system number 200. We're still going to be using our loopback 0 to source the BGP session. And right here in the last bullet point, we do not have to advertise any route at this time. So we're just going to need to bring up the BGP session. And this is between, going back to our diagram here, R3 and R6, iBGP. Okay, so start on R3. Again, let's do it manually. Router BGP 200, no auto configuration, no synchronization. BGP router ID 172.16.0.3, and then neighbor 172.16.0.6 with the remote AS of 200, which is the same AS as itself, and then the update source command from this loopback. Okay. And let's also make sure that we check our internal connectivity between R3 and R6 loopback. Again, do a show ISIS neighbor. You can see it has a adjacency with R6. Show IP route ISIS. We should be seeing R6 loopback 0 IP 0.6. And let's just do a quick ping. 172.16.0.6, sourcing from R3 loopback 0. And you can see that's pingable. Okay, so show run, begin, router BGP. Let's go ahead and copy this. Again, paste into the notepad. No auto, no sync. This is going to be for R6, so router ID 6 and neighbor is .3. Okay, switch to R6. Go ahead and paste in those commands and give it a few seconds for the adjacency to come up right here. Going back to R3, show IP BGP summary, and we are seeing the same thing with the neighbor of .6, AS number 200, and here's the uptime, 0 routes being learned. So that's pretty much all we need for task number 1. And just to make a quick note here, the reason that we usually source the iBGP session from a loopback interface, and that's because you might have the redundancy built into the network, just like what we have multiple paths to get from one router to another here. And if that direct link goes away, as long as there's a reachability between the loopback interfaces, the BGP session can be pretty much rerouted through a different path and it doesn't have to be taken down. So, and since the loopback interface never goes down, your iBGP session will always stays up as long as there's one usable path between the two neighbor routers.